Hi and welcome to my channel. I am the Mad Computer Scientist. I thought we'd go over some order of operations today. Now, if you've been paying attention to the viral math problems on Twitter and similar sites, you'll know that they spawn a lot of arguments. In fact, we're going to discuss one very common problem that has come up for a while and discuss the order of operations for logic as well, but that will be less interesting and less important to all of these problems that come up on social media. All right, so we have two problems here, and one is a problem that made the rounds a few years ago, and the problem is 6 divided by 2 times, in parentheses, 1 plus 2. And we also have a logic problem. And if you don't understand my notation, it is not, then in parentheses, not A or not B. I want you to take a few seconds to try to work out these problems on your own or pause the video. And if you're looking for a tip on the second problem and know how to work through these things, you can actually use De Morgan's law to make it easier. Okay, good. Are we back yet? Now, what was the answer to the problem? Do you think it was answer A, 9, or answer B, 1? You may have noticed when these discussions came up several years ago that there were two answers commonly given, and these were the most commonly given problems. Now, believe it or not, the right answer to that particular problem was indeed 9. Why is it not 1? It's because when we apply the order of operations correctly, and there is a typo there if you noticed, we do the parentheses first. So that gives us 6 divided by 2 times 3. Now, the next part also trips people up, and this is why you sometimes get different answers. You do the multiplication and division in order, so you do the division first. 6 divided by 2 is times 3, gives us 3 times 3, which is equal 9. Some of you are probably saying, but I got 1. And some of you may have gotten different answers. And I'm going to ask you a question. Did you assume that everything after the division symbol was supposed to be done first? If you assumed the latter, you did in fact get 1. However, there is a correct answer to that if you're using PEMDAS, the acronym most of us in the American school system learn. PEMDAS stands for parentheses, exponents, multiplication, division, addition, and subtraction. Let's go through the steps. Now, if you're going to do a problem this way, you start with parentheses and exponents. Do the grouping elements first, which we did in this problem. Now, when it comes to exponents, we want to keep in mind that exponents, if there are no parentheses involved, are done from top down. For example, 2 to the 2 to the third power. Now, after we take care of those, we go on to multiplication and division. Now, multiplication, division, and the next step, addition and subtraction, frequently mess people up. Why do they mess people up? Because people assume that the order of operations is determined by where they are in the acronym, and this is not the case. Multiplication and division have the same precedence, and they are done in order from left to right. Addition and subtraction also have the same precedence, which is lower than multiplication and division, and still are done from left to right. If you followed my example to the earlier, you notice I said that 2 to the 2 in parentheses to the third power is not the same thing as 2 to the second power to the third power. The first one, we multiply the exponents together and we get 2 to the 6 equals 64. In the second one, we multiply the 2 to the 3 and get 8, and get 2 to the 8 equals 256. And if you're wondering why I have a preference for powers of 2, well, I am a computer scientist. So why did people get 1 then? This simply comes down to how people are interpreting the problem. And they interpret it the way you see it on the screen, which is 6 over 2 times 1 plus 2 in parentheses. So why does this confusion exist in the first place? The first reason is ambiguity. When you see this type of viral math problem, keep in mind they are deliberately written so as to cause confusion, because the creator of these problems wants people to argue about them. That's why people think they are fun after all. If you got a different answer than the two I proposed earlier, you might have simply made a precedence error. Did you forget that the last four operations mentioned are supposed to be done in order from left to right? And finally, the best thing to do to avoid these arguments when we're dealing with something else that isn't designed to create arguments on social media is to avoid poor design. Don't write problems in such a way that they cause ambiguity, and if they do cause ambiguity, use parentheses or different notation to clear your intent up. So I did mention earlier that we were going to go through the logic order of operations for the programmers. And believe it or not, this type of math, and it is math, does have its own order of operations. And the logical order of operations precedence is, first we do not, then we do and finally or. Now let's return to the problem I mentioned at the beginning of this video. And we're going to do not, in parentheses, not A or not B. We're going to assume that the value of A is true and the value of B is false. So the first thing we're going to do is substitute the true and false values for the variables. So then we get not, in parentheses, not true or not false. Now, because we do not first, we now have not and then parentheses, false or true. All right, we're going to do in parentheses next. Then we do true, so we have not true. And because the not is the logical negation, we of course come up with the answer of false. If you work this out as a truth table, you can see that the problem I have given you is logically equivalent to the and statement. By the way, logical equivalence just means that the truth tables for two statements are identical. And with that being said, I'm going to bring up something I also mentioned earlier. I mentioned something called De Morgan's Law. For those of you who are interested, De Morgan was one of the math tutors for Ada Augusta King, Countess of Lovelace, who many people give credit for being one of the first programmers. The laws are this. Not in parentheses A and B is the same as not A or not B. Not in parentheses A or B is the same as not A or not B. All right, if we use these laws, our problem becomes not in parentheses not true or not false. So we now apply De Morgan's law, take the parentheses out, and flip the operator. That gives us not true and not false. So we do the not first, which gives us not false and not true. We do the not again, we get true and false. Now we do the and we find out that the answer is false. If you're a fan of electronics, you may have noticed that this means that you can use NOR gates to build AND gates. And if you have studied electronics more deeply than I have, you probably know that the NOR gate and the NAND gate are what are considered to be universal gates, which means you can use these gates to build all other gates that exist. All right, I would like to thank you for watching. Please like, comment, and subscribe to the Mad Computer Scientist channel. If you have topics you would like covered, please place them in the comments section below. Please share this video out to your friends, and may you all have a good day, and may the odds be ever in your favor.